Hello students, welcome to the part 2 of inverse Laplace transform using partial fractions. If you have not watched the part 1, link is in the description. Go and watch part 1 and come back to this part 2. In this part, we will solve the examples of inverse Laplace transform using partial fraction of case number 2 and case number 3. Let's begin with the example number 4. 3s plus 1 upon s minus 1 into s square plus 1. If you observe the numerator, degree of numerator is 1, degree of denominator is 3. Clearly, degree of numerator less than degree of denominator, and denominator is factorized into real factors. Therefore, we can use partial fraction. But if you observe the factors, the first factor is s minus 1 linear, the second factor is quadratic. Hence, we have to use the second type of partial fraction for this example. So, we have to use the mixed case of linear and quadratic groups or quadratic factors of partial fraction. So, this can be written as 3s plus 1 upon s minus 1 into s square plus 1 equal to a upon s minus 1 plus bs plus c upon s square plus 1. As s minus 1 is the linear factor, so a upon s minus 1. S square plus 1 is quadratic factor, therefore bs plus c. Cross multiply and cancelling the denominator, we get a into s square plus 1 plus bs plus c into s minus 1 is equal to 3s plus 1. Now, multiplying these two brackets, we get a into s square plus 1 plus bs square plus, now multiplying these brackets and simplifying the term, we will equate the coefficients. So we get as square plus a plus bs square minus bs plus cs minus c equal to 3s plus 1. So, combining the coefficients of s square, s and constant, a plus b into s square plus minus b plus c into s plus a minus c equal to 3s plus 1. Now, equating the coefficients, we get a plus b equal to 0, minus b plus c equal to 3 and a minus c equal to 1. Now, solving these three equations on calculator, we get the values of a, b and c. The value of a is 2, b minus 2 and c equal to 1. Therefore, 3s plus 1 upon s minus 1 into s square plus 1 is equal to 2 upon s minus 1 plus minus 2s plus 1 upon s square plus 1. Now, we will apply inverse on both sides. So, L inverse of 3s plus 1 upon s minus 1 into s square plus 1 is equal to L inverse of 2 upon s minus 1 plus minus 2s plus 1 upon s square plus 1. Now, using linearity property, we get 2 L inverse of 1 upon s minus 1 minus 2 L inverse of s upon s square plus 1 plus L inverse of 1 upon s square plus 1. Now, using the formulae for inverse Laplace transform, we get 2 e raised to t minus 2. Now, the L inverse of s upon s square plus 1 is cos at. A is 1, therefore cos t plus L inverse of 1 upon s square plus 1 is sin at upon a. A is 1, therefore sin t. Hence, the final answer for this example is 2 e raised to t minus 2 cos t plus sin t. Now, let's study one more example of this case. Let's solve one more example of the same type that we have studied in example number 4. In this example, if you observe, the degree of numerator is 0, degree of denominator is 3, denominator is factorized into real factors, therefore we can use partial fraction. Now if you observe the factors, the first is linear, the second is quadratic. So therefore this can be written as 1 upon s into s square plus 4 is equal to a upon s plus bs plus c upon s square plus 4. Now cross multiplying and cancelling the denominator, we get a into s square plus 4 plus bs plus c into s equal to 1. Therefore, as square plus 4a plus bs square plus cs equal to 1. Now, combining the coefficients of s square, s and constant term, we get a plus b into s square plus cs plus 4a equal to 1. Now comparing the coefficients of s square, s and constant term, we have a plus b equal to 0, c equal to 0, 4a equal to 1. Again, solving this three equation, we get the values of a 1 by 4, b minus 1 by 4 and c 0. Therefore, this term can be expressed as 1 upon s into s square plus 4 is equal to 1 by 4 upon s plus minus 1 by 4 into s plus 0. We will not write down 0. So, simply we can rewrite this as minus 1 by 4 into s upon s square plus 4. Now, taking inverse Laplace transform on both sides, we get L inverse of 1 upon s into s square plus 4 is equal to L inverse of 1 upon 4 upon s plus minus 1 upon 4 upon s square plus 4. Now, using the linearity property, this can be rewrite as 1 by 4 L inverse of 1 by s minus 1 by 4 L inverse of s upon s square plus 4. Hence, the L inverse of 1 upon s is 1. L inverse of s upon s square plus 4 is cos 2t. So, our answer is 1 by 4 into 1 minus 1 by 4 cos 2t. As the denominator is same, so L inverse of the given example is 1 minus cos 2t divided by 4. So, example number 4 and example number 5 both are related with the type number 2, where the factors are quadratic and linear. So, combination of quadratic and linear factors. Now, let us discuss another case of inverse Laplace transform using partial fraction. In this example, we will study if the factors are repeated, how we can find the inverse Laplace transform. Now, if you look at the degree of numerator, it is 0, degree of denominator is 3, and the factors are real, therefore we can use partial fraction method. Now if you observe the first factor, it is s square, so it is repeated, and this is s plus 1 linear factor which is non-repeated. So this is the case, combined case of repeated and non-repeated factors. So this can be written as 1 upon s square into s plus 1 equal to a upon s plus b upon s square plus c upon s plus 1. Now, for this, we cannot just simply cross multiply. What we will take? We will take the LCM of the denominator. So, if you observe the denominator s square, s plus 1. So, the LCM of these terms will be s square into s plus 1. So, if we take the LCM, s square into s plus 1. For this term, s and s plus 1 is missing. So, multiplying by s into s plus 1 with a plus, for this term s plus 1 is missing, so multiply b with s plus 1 plus, for this term s square is missing, so multiply c with s square. So for this case we cannot take the cross product, we will take LCM of the denominator by this method. So denominator get cancelled, so we get as into s plus 1 plus b into s plus 1 plus cs square equal to 1. Now let's multiply the terms and equate the coefficients. Here we get as square plus as plus bs plus b plus cs square equal to 1. Therefore, combining the coefficient, we get a plus c into s square plus a plus b into s plus b equal to 1. Now comparing the coefficient of s square, s and constant term, we have a plus c equal to 0, a plus b equal to 0 and b equal to 1. So solving these three equations simultaneously, we get a equal to minus 1, b equal to 1 and c equal to 1. If we solve this equation using calculator, these values can be easily calculated. So replacing this value, we get 1 upon s square into s plus 1 equal to minus 1 upon s plus 1 upon s square plus 1 upon s plus 1. Taking inverse Laplace on both sides and using linearity property, we get minus L inverse of 1 upon s plus L inverse of 1 upon s square plus L inverse of 1 upon s plus 1. Now, L inverse of 1 upon s is 1, L inverse of 1 upon s square is t, and L inverse of 1 upon s plus 1 is e raised to minus t. Therefore, we get answer minus 1 plus t plus e raised to minus t. So, in this example, we have studied the last case of partial fraction where one factor is repeated and another one is linear or quadratic. So, this is the example number 6. Let us discuss one more example of the case where the factors are repeated. Now, if you look at this example number 7, degree of numerator is 2, degree of denominator is 3, and the denominator is factorized into real factors. Therefore, we can use partial fraction. If you observe the factor, the first factor is repeated and the second one is linear non-repeated factor. Hence, this can be written as s square minus 2s plus 3 upon s minus 1 whole square into s plus 1 equal to a upon s minus 1 plus b upon s minus 1 whole square plus c upon s plus 1. Now, let us take the LCM of the denominator as s minus 1 square into s plus 1. So, we get in the denominator s minus 1 square into s plus 1. Now for the first term, there is missing term is s minus 1 into s plus 1. Let us multiply with a. So a into s minus 1 into s plus 1 plus, for the second term, s plus 1 is not there. So multiply b with s plus 1, and for the third term, s minus 1 square is missing. So multiply c with s minus 1 whole square. Now cancelling the denominator, we get a into s minus 1 s plus 1 plus b into s plus 1 plus c into s minus 1 whole square equal to s square minus 2s plus 3. Now let us multiply the term and equate the coefficients. So we get a into s minus 1 into s plus 1 is s square minus 1 plus b into s plus 1 as it is plus c into s minus 1 whole square s square minus 2s plus 1 equal to s square minus 2s plus 3. Now let us combine the coefficients. So a s square minus a plus bs plus b plus cs square minus 2cs plus c equal to s square minus 2s plus 3. So a plus c into s square plus b minus 2c into s plus minus a plus b plus c equal to s square minus 2s plus 3. Now equating the coefficient, we get the equations a plus c equal to 1, b minus 2c equal to minus 2, and minus a plus b plus c equal to 3. Now solving these equations on calculator, we will get the values of a as minus 1 by 2, b equal to 1, and c equal to 3 by 2. So with the help of calculator, you can easily calculate these values. Replacing these values in the equation, we get s square minus 2s plus 3 upon s minus 1 whole square into s plus 1 is equal to minus 1 upon 2 s minus 1 plus 1 upon s minus 1 whole square plus 3 by 2 upon s plus 1. Now, taking inverse Laplace transform and applying linearity property to this term, we get L inverse of s square minus 2s plus 3 upon s minus 1 whole square into s plus 1 is equal to minus half L inverse of 1 upon s minus 1 plus L inverse of 1 upon s minus 1 whole square plus 3 by 2 L inverse of 1 upon s plus 1. Now, if we take the L inverse of the first term, it is e raised to t. Now, for this term, if you observe, if the square is not there, so we have 1 upon s minus 1. So, the inverse is e raised to t only. But when we are having a square, so it will be multiplied by t. So, the L inverse is t into e raised to t. Therefore, if we take the L inverse of the term, the first term will be e raised to t. The second is t into e raised to t, and the third is e raised to minus t. If we replace this value here, we get 1 by 2 e raised to t plus t e raised to t and 3 by 2 e raised to minus t. So this is the inverse Laplace transform of the given example. In this video, we have discussed 4 examples of inverse Laplace transform using partial fractions of the cases where the roots are or the factors are quadratic or the factors are repeated. I hope this video is useful for all of you. If you have not subscribed our channel, subscribe our channel Math with GG